Welcome to part 2 of the lecture video. So we said that after you are done calculating for your reactions and you do your check, you come and redraw your free body diagram, and then you represent all the hot forces around it. Exactly. This is our left hand side, this is our right hand side. We took a cut at AB. When we took a cut at AB, we calculated for the shear force values. We also calculated for the hot bending moment values. Yes. So now we are going to take portion BC and then we calculate for its bending moment value, since we already did for its shear force value in part 1 of the lecture video. Please remember to subscribe to the channel, like the video, and also share for more. Very good. So in taking of the moment, we said that always you do what to put down your rule. Once you put down the rule, life is much more easier. This is our origin. This is where we're going to be standing with the compass. If you open to here, you realize that the distance of x is covered. So if you take the moment, you realize that this is going to be a hot. This is going to be a clockwise moment. So it's going to be hot negative 20 times x. Okay, so let's put it into this bracket. I'm going to write hot negative 20. The negative came as a result of the clockwise moment I took. So 20 times what x. Then from here, what are we going to do next? We are done taking that moment, so let's take it off. Then this one, the next one we're going to take is, this is going to be our hot. This is going to be our pivot, and then we stand over here with a pencil. You take the moment. Which kind of moment is this? This is an anti-clockwise moment, so it is positive. So you bring your sign positive. You bring your sign positive. You bring your sign positive, and then from there you can proceed. Okay, so this is going to be also 20 times what? X minus 3. You see, and so this is it. So I'm going to write out 20 times x minus 3. You see, yes, times x minus 3. So that is the x minus 3 into bracket you are seeing over there. Then I can close this bracket now. You see, then what's going to be the next person I'm going to bring? The next moment over there is the anti-clockwise moment, the one that came with the rule. That is the one that this one. This is the next one we are going to consider. So this is hot positive. I'm going to put hot plus m. You see. Now the rest is no more physics. The rest is mathematics. So we can simplify and then we are good to go. Very good. Good students should do well to ask more questions. You can type your questions in the comment section. I'll do all to review them for you. And life is going to be much more easier. Very good. Also do all to solve the trial questions. Very, very, very important. Try and then solve the trial questions. Send them to me. I'll review them for you so that we can all be on the same side. Okay. Okay. So from here, what are we going to do? This means that 20 times s is going to give us minus 20x. Okay. Plus what? This time this is still going to give us the same thing. So this is going to be 20 and then bracket open x minus 3. As simple as ABC. Okay. Plus the moment. plus the moment, all is equal to what? 0. All is equal to 0. All is equal to 0. So from here, we're just going to group like terms. Okay, we can let the m be here and remove everyone to the right hand side. So we said that m is going to be equal to what? 20x plus m is going to be equal to what? 20x plus what? Because if it cross the equal to sign, it's going to be what? Positive. So this one is not going to be plus, but it's going to be minus, okay? Because if this guy is positive here and it's cross the equal to sign, it's going to be negative at the other side. So you see here is going to be what? Minus 20 and then bracket open x minus 3. Okay, as simple as that. As simple as that. So from here, we say that we can call this a linear variation. Okay, because you can see that there is no exponent like x squared in it. You see. So that is the trend. So I can write this over here since this is our answer for the moment. This is a linear variation. Take note that the moment is measured in what? Kilonewton meter. Yes. So this is a constant variation. At least a linear variation. So let's put it over there. Linear variation. You understand me? So that is it. So from here, I'm going to do what? We're going to compare this to the intervals. You see, I'm going to compare this to the interval. So we are going to do at x is equal to what? 3 meters. Let me show you with 2 pages. So this is it. Okay. So this is how we are going to work the intervals out. And it is as simple as that. So at x is equal to 3 meters, our moment at b is equal to what? 20x minus 20. Okay, but anywhere we see x, we are going to put what over there? We are going to put this 3 over there. You see, we're going to put that 3 over there. So let's all write together. And that is here is going to be what? At x is equal to what? 3 meters. Our what? Moment at b. Because the portions we are using is what? BC. So we are going to talk about in terms of the B and what? C. So the moment at B is equal to what? So we're going to write this relation, but anywhere you are going to see x, you put 3 over there. You see, then you punch in the calculator, you simplify. So we're going to say 20 into brackets or 3. Okay, minus 20 into brackets what? 3 minus 3. And this 3 minus 3, what is it going to give you? 0. So finally, our final answer for this is going to be what? 20 times 3 is going to be what? 60. So we are going to get 60 kilonewton meters. But it is positive. So moment at B is equal to what? 60 kilonewton meters. That is the unit. You remember to add a unit so that you don't get penalized. Okay, so we come and do the same thing for the other one too. So at x is equal to what? 6 meters. We come and do for this too. So we come and say that what? At x is equal to 6 meters. At x is equal to 6 meters. Our moment at C is equal to what? 20. This time, wherever we're going to see x, we're going to put what over there? 6. We are just writing this relation. But wherever you see x, you put the variable of x over there. So this is 6. Minus what? 20 into bracket what? This is going to be what? 6. Because this 6 is here, that's why I'm writing this 6 over here. Minus what? 3. At the end of the day, what is that going to give you? You realize that that is going to be what? Punch it on the calculator and tell me the answer. Punch it quickly on the calculator. You realize you're going to get 60 kilonewton meters. Okay. So this is also going to give you 60 kilonewton meters. As simple as that. So we're going to take our last cut to calculate for it. Let's say shear force and bending moment, and then we are good to go. You understand me? And then we are good to go. If you like, you can consider the right hand side. If you like to, you can consider the left hand side. It's a choice, whichever one that you think is most favorable for you. You can apply it. You understand me? Good. So this is how far we have come. Good students should do all type their questions in the comment sections, and I'll do all to review it for them. Also, don't forget to like the video. Don't forget to like the video. You understand me? Subscribe to the channel and also share for more. Good. From here, we are going to take our cut at portion hot C, D. Then we draw the diagram. That is obviously the last thing we are going to do. So let me clean all of this one. But where we are going to take the cut this time is hot. Yes. So we are taking the cut. So let me clean all of this. Let me clean all of this. Yes. So you see, this time I'm going to take the cut over here. So this is CD. If you want to consider the left hand side, you can imagine how long it is going to be for you. If you want to consider the right hand side too, you can just imagine how long it is going to be for you. In this case, this is the right hand side, just this small one. Yes. So this part is going to be your right hand side. You see. Yes. So you can choose to consider the right hand side, whichever way. I wish we consider the right hand side so that you can have a blend of understanding. Exactly. So we are going to consider the right hand side. Yes. We're going to consider the right hand side. As simple as that. Yes. So what are we writing over here? Portion hot. This becomes our portion CD. Yes. Portion C. So we're going to put over here portion hot. portion C, D. Okay. But you realize that since we are considering from the right hand side, it is like we are counting from what? Let's say right to left. Okay. So in other words, we said that what? DC. DC. Portion DC. You see, because we are considering from what? Right to left. That is the right hand side. So because of the description, that is why I'm saying this. Okay, yes. So let's just have a look. Then over here, since we are done, what are we going to say? So we are considering the right hand side. Considering the right hand side. So right hand side. And that is going to give us what? Better still, to enhance understanding, I could use a different color pen to denote this. Yes, so let me put it over here like this. So now you can see it. So this is the hot right hand side. Okay. I think this is more understandable. So let me put it over here like this. Okay. So this time we say we are considering the right hand side. So the interval is going to be hot. Look at the intervals that we are going to use. It's going to be hot. Okay, let's go back to the diagram. This is the diagram over here. Okay. So if we are considering the right hand side, it's just from 0 to 3. That is the interval. Because you are starting from D to C. You see. So it's like we are moving like this. So you see. So you start from 0 to 3. So it's going to be what? 0 is less or equal to x less or equal to 3. That is the simplest way. Okay. So let's write the interval together. And that is the interval is going to be what? 0 is less or equal to what? X less or equal to what? 3 meters. From here, we are just going to draw the diagram. Okay. Yes, the left hand side itself. We are now going to draw the left hand side we are talking about. So you realize that this is how it looks like. Something like this. This is it. Okay. The left hand side is what we are drawing over here. And then from there, what else are we supposed to do? Let's go back to the diagram and have a look at something. So let's assume the cut here. The cut was over here like this. So here was 20 kilonewton. The reaction at D we calculated for. You see. Then from here to here is X. Right hand side, simplest. Calibrate here. Calibrate here. So from here, let's go back to the diagram and have a look at it one last more time. Let's go back to the diagram so that you can have a look at it one last more time. So you see, this is the diagram over here. You see, so this is it. This is what we have drawn over there. You understand? So when we cut here, this is the 20 kilonewton. So the D side you saw, that is the cut. Okay, let's proceed. So over here, we are going to pull down my origin. And then the origin is what? I just put it down like this. This is the origin. Small. Then from here, I can pull down the sign. You see. Over here, realize that the sign is going to change because we are considering the right hand side. You see. So the sign for the right hand side is what? You realize that the first one is moving towards the north. Okay. The other one is moving towards the what? West. Okay. So this is it. And then the moment is a clockwise moment. The moment is a clockwise moment. So this is it like this. We are seeing over here. The moment is a clockwise moment. You understand? And so this is the moment over here like this. That is the moment over there like that. Very good. So let me write the values attached to it. This is our neutral axis. As usual, as you know, this is the moment of consideration. And then this is the vein. I told you about vein. That is the shear force. You see, vein is the shear force. Vein is the hot shear force. So from here, we can now start the work, and life is much more easier. What is the first thing we are going to calculate for? The first thing we are going to calculate for is our shear force values. Okay. The first thing we are going to calculate for is our shear force values. So let's do that quickly. This is my shear force values. So this is the shear force values. As simple as that. So when you write the shear force values, you come and pull down the sign conversion that we are using. You see. So this is the shear force values. And then we have to come and pull down our sign convention. So the sign convention is what? We are taking all forces that are moving in the y-axis, that is towards upwards to be hot positive, towards the north to be positive. So that is what? Sum of all forces moving in the hot y-axis should be equal to what? 0. From here, what are we going to do next? This implies that our shear force values, have a look. They are just the people that are moving in the y-axis, I told you. So this 20 kilonewton is moving in the y-axis. So it is, this guy is moving upwards, this guy is moving upwards. So it's going to be what? Minus 20 minus what? V. Okay, or you can write V because V is moving upwards. It is what? Positive. Okay, because V is moving upwards, it is positive. So you come and write what? Positive V plus what? Positive 20 is equal to 0. Okay, that is what we are going to write. So have a look. That is what? Positive what? 20 plus what? V. And the V is the shear force is equal to what? 0. At the end of the day, if you make V a subject, what are you going to get? If this 20 cross the equal to sign, it is going to be what? Negative. So you're going to get negative 20 kilonewton. As simple as that. So this is also a constant. As simple as ABC. This is also a constant. write over here constant. Okay, very good. For me, what are you going to do next? We are going to consider it in terms of what at D and then also at what C. You realize that from here, from our portion that you wrote, the portion, how did I write the portion? I wrote it in terms of what DC. I wrote the portion in terms of DC. To draw your mind to something again, let me show you something. Yes. So this over here, I can just change color to highlight it and write what DC so that you see it well. So since it is what D I wrote first, I'm going to consider for D first. You understand me? D came before C. Portion DC. This time we are counting from right to what? Left. It's not like the left hand side they are counting from left to right. So you say A, B, C. No, this time it's right to left to DC. So first I'm going to say at D, you see, at what? X is equal to what? At X is equal to 0. Moment shear force at what? D is equal to 0. Then we come and do for the C2, then I'll use the 3. That is what I'm going to be doing. So we'll just have a look and see something. So here is going to be what? At X is equal to what? 0. At X is equal to 0. My what? Shear force at D is equal to what? Negative 20 kilonewton. Because it is D that I wrote first, portion DC. They also come and do the same thing for the C. At what? X is equal to what? 3 meters. Our what? A shear force at C is going to be what? Negative 20 kilonewton. I wrote constant over here because you realize that this has no X attached to it. It has no variable attached to it. You understand me? And so it means that it is a constant. Very good. Very good. Okay, let's proceed. So from here, we are done calculating for the shear force value. We are going to calculate for the bending moment value. Then we are good to go. So we are also coming to calculate for the bending moment values. Okay. So let me put that over here quickly. Then we will go and plot a graph. So this is the bending moment values. So bending moment values. So you see the bending moment values. From here, we are just going to put down the rule as simple as that. So bending moments, sometimes you can say what PM. Okay, yes, the PM values. As simple as ABC. down the rule, and the rule we are going to use. So we are going to say that what we are taking all anti-clockwise movements to be positive. Okay. So we say that what sum of all movements, the same rule we have been using since day one is still what I'm using. Yes, so sum of all movements about the origin O should be equal to what? 0. Always put down the rule. Then we can proceed. You realize that now I can go and take my moment. Okay, yes. So let's start taking the moment now. Let's all take the moment now. Just with this diagram we are seeing over here. So you see, if this is the diagram and then you are standing here with your compass, this is your pivot, you open to this side, the distance of X is covered. If you take the moment like this, if you follow the direction of the arrow, which kind of moment are you going to take? You're actually going to take an anti-clockwise moment. An anti-clockwise moment is what? Positive. You see, an anti-clockwise moment is what? Positive. So that is going to be what? Positive what? 20 times X. Okay. Then at the end of the day, what is happening? There is no other force to multiply with any distance again. So the next thing we are going to do is that we consider this moment. We will consider this moment. So this moment is what? It is actually a clockwise moment, you see. So we say minus what? M. Minus M. So at the end of the day, since there is no other person, we equate all of these to what? 0. You see, we equate all of these to 0. So this is going to give us what? 20x. 20x minus what? M. If you make let's say this M the subject, what are you going to get? Okay, we can move the M to the right hand side. So that is going to give us 20. That is going to give us what? That is going to give us 20x is equal to M. X is equal to what? M. Since the one I told you that if they say A is equal to what? B, then it means that what? B is also equal to what? A. So finally, we can say that what? Our M, we can say that therefore our M is equal to what? 20 what? X. But because X is attached to it, how are we going to call it? The name we are going to give to it is what? A linear what? Variation. Remember that this is moment. So the unit is what? The unit is kilonewton meters. So I'm going to write over here linear variation. So this is a linear variation. Good students should do what? To have a pen, a paper, and a calculator beside them so that they can practice what I'm doing over here. This is a practical course. Failure to practice it can really affect you. Okay. So to be on a more safer side, practice it as you watch the video. Okay. So this is a linear variation. So from there, we are just going to consider at what? D and also at C. You understand me? So at X is equal to 0, our moment at D is equal to what? 20, and you put 0 into the bracket, and you say that we are going to get the moment at D. It is the same thing whether you are considering the right hand side or the left hand side. You see, the laws of physics are the same for all observers in a uniform motion relative to one another. No matter how you apply them, at the end of the day, they still speak the truth. You understand me? Yes, provided you are applying them the right way. You understand me? So let's go and do our, let's talk about this quick, and let's draw a diagram. So this is what at this x is equal to what? At x is equal to what? 0. You see, command. Then we say that what? Moment at what? D, because it's D that came first. So moment at D is equal to what? 20 into bracket. You put a 0 over there. So 20 times 0 is what? Is it not 0? So at the end of the day, we are going to get what? 0 kilonewton meters. 0 kilonewton meters. Then we also come and do for the other one too. At x is equal to this 3 meters. So you see that what? At x is equal to 3 meters. At x is equal to 3 meters. Our moment at what? C is equal to what? 20 times 3. 20 times 3. And 20 times 3 is going to give you what? You're going to get 60 kilonewton. So this is going to become what? 60 kilonewton meters. Kilonewton meters. Okay. So from here, as simple as that, we can just go and draw the diagram because we are done taking all the caps. Okay. Better still, to aid those who want to take screenshots, I'm going to scroll through so that you can take the screenshot to enhance your understanding. Okay. So this is how far we have come. This is how far we have come. You see, yes, this is how far we have come. We are done taking all the portions. We are done taking all the portions as you have seen. It is just portion, the last one that we consider the right hand side. But from all we have been considering the hot left hand side. Over here, you see that we consider the hot left hand side. That is portion BC, and portion hot AB to consider the hot left hand side. As simple as you are seeing over there. So if you want to take some screenshots, you can pause at certain stages and take the screenshots. As simple as that. Good students should do all to type their questions in the comment section. I'll review it for them, and then life is going to be much more easier. Also, I'm going to drop the link to my Telegram in the comment section, and it's going to be pinned. Do all to send all the solutions to your trial questions through there. I'll check them out for you, and life is going to be much more easier. You see this, after doing the check, after we did a check over here, we came to do the free body diagram again, and then we represented all the reactions around it. You see, now we are going to draw this same diagram again at the end of the day, and then after drawing this diagram, we are going to use that to plot the graph. You see, I'm going to redraw this again and use this to plot the graph. So look, I'm going to the last page. I'm going to take a fresh page, and then we use that to plot the graph. We come and take the values and then use them to what? Plot the graph. So let's proceed. Let's proceed. we are going to do that over here on page 11. So let's quickly draw the diagram. Let's all do that together. So this is the diagram over here. Do all to manage the space. Because we'll be writing certain things at this side. Let's leave that place. So this is our 20 kilonewton. It's also our 20 kilonewton. So over here we have P, and over here is A. Remember we have two forces. Let's say two loads acting on the beam. It was a simply support beam. This was what? 20 kilonewton. And then this was also what? 20 kilonewton. Okay. Here became also what? 20 kilonewton. And this is also our what? 20 kilonewton. So we have to just dimension it, and then we can start plotting the graph. For the diagram there, you just have to learn how to draw it, because you'll be drawing it more and more and more and more. So this is also 3 meters. This is also what? 3 meters. Also 3 meters. This is also what? 3 meters. This is also what? 3 meters. So let's calibrate it well. We can just go and start plotting the graph now. Okay. This does not require a graph sheet. It's just a freehand sketch. So you see what I'm doing over here? Yes. You do the same thing at your end. Try to do the same thing at your end. So we use broken lines. Create these imaginary lines right here. So we are going to plot for the shear force first, and also we come and plot for what? Bending moment. Okay. Depending on the space we'll be having available. So that is it. That's it. And let's add the last one. Let's add the last one. Let's add the last one. For me, what am I going to do next? I'm just going to cut a straight line like this through it, and then I'll consider this one to be my hot shear force diagram. Okay, so I'm going to write over here what shear force diagram. Okay, so from here I can just add a unit. You see, so look at this is a unit. It is measured in what? Kilonewton. Kilonewton. It's measured in kilonewton. Yes. It's measured in kilonewton. So it's measured in kilonewton, just as that you are seeing over there. So from here, what are we going to do? So we take here as the origin. You see, this place is going to be the origin. And then if here is the origin, you realize that we take here as our reference line. Okay. So this upward zone is going to be what? Positive. You see, yes. It's just like using the graph. Let's take this line as our y-axis, and then this place is going to be what? We consider this zone as our negative zone. You see, as simple as that. So from here, we can now go and pick our values, and then we begin to what? Plot. know anything difficult. So if here is 0, you can assume that here can be your 10, by that 20, 30, it continues. If here is 0, you assume that here is -10, -20, -30, it continues. It's an assumption. Do you understand me? For 0 shear forces, we can plot them on the line. Do you understand? On the shear force line. So let's plot the shear force value. If you are done, we come and plot the bending moment values. Okay. So from here, let's go to where we started the calculations. So we are going to pick the values because of time, and then we come and plot them quick. Then we are good to go. So this is where we started. Let's go to portion AB. Portion AB, our shear force values was what? The shear force at A is 20, and then the shear force at B is what? 20. You see, keep that in mind. At portion AB, the shear force at what? This is the shear force value. The shear force at A was what? 20. The shear force at B was also what? 20. Also at portion what? BC, you can be writing them down. At portion BC, the shear force at what? B was what? 0. You see, the shear force at B was 0, and also the shear force at C was what? 0. So let's go and plot these values and come back. Let's plot these values and come back. And so look at it. Look at it carefully. So this is what we're having over here. So A, the shear force value for A was what? 20. So this is the A over here. If this is A, so at 0, 10, 20. You see the shear force value for A, it is 20. So I put asterisk over here, and then I can write over here what? 20, because it's a plot. I'll be plotting a value over there. 20 kilonewton. Then at P2, you realize that the shear force value over there was 20. You see the shear force value at P. It was 20. This shear force value at P, that is over there. It is 20. So let's go and put it here. So that is it, 20 kilonewton. So this is also 20 kilonewton. Like that. 20 kilonewton. Okay. At C, it was 0. The shear force at portion, when we were considering portion B, let me quickly dimension this one. This is portion B, and then this is portion C. Yes. So when we're calculating for the shear force value at C and D too, you realize that, look at it, at portion CD, at portion BC, look at portion BC. If this is portion BC, the shear force value at portion BC was what? It was 0. Okay, B was 0, and then C was 0. That's portion BC. So let's go and plot it together. So that is what we put 0 over here. We come and put 0 over here. So I'm going to put 0 over here. So that is 0 kilonewton. So that means that a point will be here, and also a point is going to be here. That's 0 kilonewton. So this also becomes a 0 kilonewton. But let's put it over here. 0 kilonewton. Then from there, what are we going to do next? Let's go and plot the portion DC. Okay, let's go and plot portion DC. So when we're doing portion DC, you saw that the shear force value, look at this is portion, not portion DC. Okay. The shear force value at what? Watch, the shear force value was what? At D was -20 and at C was what? -20. So those are the values we are going to be using. So we see negative, it means that we'll be coming to the negative zone and come and plot it over there. So if this is 10, then it can be 20. So -20. Put it over here. Okay. So over here, we're going to write what? -20 kilometers. Then over here too, we're going to have 1 over there like that. Here too is going to be what? -20 kilometers. -20 kilometers. So from here, we can just join it. We join it and then we shade. Do you understand me? Yes, so let's join it and then let's shade. Let me use a different color pen to join and shade it so that at least your understanding can be enlightened. So I join this one to this, like this. Join this to this. Since this is in the positive zone, I can write positive over here and I shade inside, like that. Then this one too, it follows the number line like that. Then you come over here. This is what? So this will come like this also. Then we join this to this. Okay. So very beautiful. Very beautiful. This is in the negative zone, so I put negative over here like this. Then we shade it. Shade inside. Very, very nice. Very, very nice. Very, very nicely. So from here, what do we go and do? We're going to plot the hot. Let's go and plot the bending moment values also. Then we draw the bending moment diagram. Okay. So we are done drawing the shear force diagram. We've gotten the map. Okay. We've gotten the map. Then from here, what are we going to do? We come and draw the bending moment diagram also. Okay, so it's the same procedure. Don't get confused. Let's draw the bending moment diagram. So we extend this line small. And we take our reference point. Okay. So this is the line we are using. So we are taking this line. And then over here too, now we can say that this is going to be our bending moment diagram. So this is kilonewton, this kilonewton meters. So this is my origin. Okay. Since this zone is a negative zone, I can write positive over here. As simple as that. It means that we are coming to plot all the positive ones over here, then the negative ones will be at the top. Is it not beautiful? As easy as ABC. So we are going to plot the values like that. Okay. So first of all, we are going to go to portion AB. We look for the bending moment value at A. We look for bending moment value at B. We come and plot. Also come and go to portion of BC. Then we come and do for portion DC like that too as well. You see. So let's go to portion AB. Let's go to portion AB. Let's go to portion AB. So in portion AB, this is our portion AB over here. So the portion AB, our bending moment value was what? Oh, at A, MA is equal to what? 0. You see, MA is equal to 0, and MB is also equal to what? 60 kilonewton. Okay, so we are going to plot it 0 and 60. Okay, then we'll come back and plot the rest. So let's plot it. Quick. Let's plot it together. Let's plot it together. Okay, so this is it. So the first one is 0. Okay. So we're going to put over the 0 kilonewton. 0 kilonewton, that is MA. And then the other one is 60. MB is what? 60. It is 0 kilonewton meters. And this one is what? MB. So if we are calibrating this 0, let's say 10, 20, no, let's say the interval we want to use over here is 60, is 20, 20, 20 interval. So what do you think is going to be? 20, 40, 60. Okay, it's an assumption. So look at 20, 40, 60. So the 60 is going to be somewhere here like this. So let's put our 60 over here. So I'm going to write over here what? 60 kilonewton meter. So this is 60 kilowatt meter. Okay. Then we're going to plot the other one. So we are coming to go to what? Portion BC. We're coming to go to portion BC. We're coming to go to portion BC. So look at portion BC to also carefully. If you look at portion BC, this is portion BC, and portion BC, its bending moment value MB is what? 60, and then what? MC is also what? 60. Okay, so we're just going to stipulate that on the graph. Let's do that quickly. So this one is also 60. So MB is 60, so we've put it over there already, so no need to put again. And then over here to we say we are getting up. So we just put it over there, we write it nicely, we are good to go. We are good to go. So this becomes what? 60. So this is also 60. So I'm going to write over here. It's positive, okay? That's why I'm writing in the positive zone. 60 kilonewton meters. So from here, let's go to portion DC and let's come and plot the last one. Look at portion DC. This is portion DC over here. And portion DC, this portion DC, realize that for its bending moment values, the bending moment values we had were what? At MD was what? 0 kilonewton, but MC was what? 60. So MD, take note, MD is what? Moment at D is what? 0 kilonewton. But MC, you already know is 60. Over here to its complement is 60. So that's good. So the bending moment values, you can see that they are reflecting with one another. Yes. So let's go and we plot this. So that is going to be what? MD is 0. You see, MC is already 60. We put it over there. So this is our last one we are plotting. So this one also gives us 0 kilonewton. diagram. So from here, we can just join the line. And because this is a positive zone, I can write positive over here, then we shade inside positive. So this is the shear force and bending moment diagram. This is the shear force and bending moment diagram for the simply support question we started solving from part 1 to part 2, and this is how far we have come. Okay. Good students should do well to type their questions in the comment section. Do well to ask more questions to enhance your understanding. Failure to ask questions will curtail your understanding, because if you ask more questions, that is where I will know the problem you are solving from, and then the help to give you. Better still, if you find the video very, very helpful, don't forget to throw $1 on my name if you see me in groups, in person, one-on-one, etc., etc., etc. Also, remember to subscribe to the channel so that anytime I drop a lecture or release a lecture video, you will be given a notification so that you can watch. Life is much more easier. Don't wait till exam time before you start to learn seriously. Last days are dangerous, so do well to understand it from basics. Do well to understand them now, so that in exam time you just watch them like what? Revision, and then you go and write the paper. Okay. What I'm doing over here, I'm just shading. Okay, at the end of the day, you choose to shade inside, and then life is much more easier. The shading, you can do it how you want. Okay? Just shade inside. As simple as that. You can choose to shade inside. As simple as what? ABC. Okay. So that is it. That is it. This is how far we have come. This is how far we have come. Okay. Yes. So that is the shear force and bending moment diagram for the problem that we just looked at. Okay. Yes, for the problem that we just looked at. Let me just take a summary. Let me just give a recap, and then we see how best we can bring the lecture to an end. The problem asks us to draw the shear force and bending moment diagram, okay, of this beam over here. First of all, what did we do? We calculated for the reactions, okay, so that the reaction should be one of the things you should always look out for. We calculated for the reactions, and then after calculating for the reactions, we came to do a check, okay. But even before you calculate for the reaction, you draw the diagram again. That is your given. Then you come and consider, you come and draw your free body diagram again. That will be you given marks. Don't forget that. You come and take moment at A. You come and also take moment at B. You do your check. If you don't get 0, it means you have a problem. From there, remember to consider all horizontal forces, because if the calculation of reaction A gave 5 marks, considering of the horizontal forces will also give you the same 5 marks. Okay, remember to put that down. You come and write your reaction again, draw a free body diagram, and then you attach the forces to it. Okay, you take the cut at portion A, B, you draw, you calculate for its shear force and bending moment. You come and take the cut at portion B, C, then you also solve for its shear force and bending moment values. You come and take the cut at portion D, C. You can choose to consider the left-hand side or the right-hand side. To make life much more easier, I chose the right-hand side because this diagram is very simple. Yes, so I took the right-hand side, and then I calculate for the shear force value. We calculated for the bending moment values. Anyhow you do it, you still get the answer. If you choose the left-hand side, you get the answer. If you choose the right-hand side, you get the answer. The laws of physics are the same for all observers in a uniform motion relative to what? One another. From here, we came to draw the free body diagram again. That's what we use to plot the graph. We said the graph, you cut 2 lines. This becomes your shear force diagram. This becomes your bending moment diagram. And then you take your origin, then you just plot the values. You take the values and plot them against. Okay. Do well to solve the trial questions. Send them to me on Telegram via the link I have posted in the comment section. The link has actually been pinned. Send me the question. I will review it for you, and let's get more interactive. Thank you all for your time. Bye-bye.